Hello everyone. We are continuing our topic on area, and we have another new figure tonight, and tonight we are talking about triangles. And again, if you ever are in need of a formula, where do you look? That's right, you look at your FCAT reference sheet. So let's just discuss where the formula actually comes from, and then we'll work out a couple of examples and we'll be done. Should be a nice short video. All right, now, as a review, if you remember this shape, if I even draw it on here, you should know exactly what that is. I'll even put in the little right angles. What shape is that? That's right, it is a rectangle. All right, and the area of a rectangle is simply the base times the height. You could use this as your base, but remember this is also can be a base. Your height matches this height over here. So you just pick one of them, either this one and this one, or a combination, base times height. Now where the triangle comes into play, and the reason I'm showing you this is because you could probably get these formulas without even looking at the reference sheet if you actually thought just a little bit about them. So what would happen if I took my rectangle there and I made a cut right across there? Okay? Think for a second to yourself, or out loud, because there's probably no one else listening to this. Think about what would result if I could use scissors and cut along that dotted line right there. And then after I cut that dotted line, I actually separated the two shapes that resulted. What are the two shapes that you get? See how I separated those? So I made a cut, and now I have two shapes. Do you see what the shapes are now? All right, what if I turn them so you can actually see what both of them are? All right, now I've rotated them, and what do you guys see? I see one triangle here and one triangle here. So essentially, if I knew the area of our original rectangle, and let's go ahead and put that in. What if the rectangle that I originally had was 6 by 8? Okay, what is the area of that? Let's just go ahead and calculate it. Our base is 8, and our height is 6. If we multiply those together, we get 48 units squared. I gotta get my little 2 in there. All right, so if I were to take my dotted line and draw across here, just like I did, and cut along that, can you make a guess as to what you think the area of each one of the resulting triangles is going to be? So if I cut that in half, just like that, and I turned them upright, what is the area of this? And what is the area of this one? If you had to guess, what would you say it was? Did you say 24 units squared? If you didn't, think for a second, how did I get 24? That's right. I started out with 48 over here, and if I were to simply just cut it exactly in half so that I got two triangles, my answer would be 24. So the area formula, or the cheat, for a triangle is simply taking the base of that triangle, multiplying it times the height, and then taking both of those after you get your product and dividing by 2. Okay, so let's talk about this. Let me erase these little ones, and I'm going to put the numbers in that match the rectangle that's over there. The height on both the rectangles, on the rectangle was 6, so therefore the height is going to be, and I've turned them sideways, is 6, because remember we flipped them over. Now those are the bases. They turned out to be the bases. Then our height was over here at 8. So if I put the area, if I substitute in for B and H, B is going to be 6 times 8 is the height, and then after I multiply those two together, I'm going to divide by 2. All right. So the area here, if I did snow cones, this would be 48 divided by 2. Do the math. Area equals 24 units squared, which is exactly what we came up with when we just thought logically. If you take a rectangle, cut it in half, that'll be half the area. All right. Okay, so let's actually just do a couple of examples and then we will be finished. All right, here I have a standard triangle. It is a right triangle, which is important because we need to know what the height and the base are. I go to my reference sheet because I can't remember what the formula for the area of a triangle is. And I find it on there, and this is what it says. It says the base times the height, all that divided by 2. All right, so now I have to determine which number is the base. Is 8 the base, the 10 the base, or the 12? I figure out that the 8 is actually the base. Okay? Now I'm left with 2 other numbers. So I already got rid of this one. It's being used. How about the 10 or the 12? Which one do I use? Now remember the doctor's office. I'm going to keep saying that because that's going to help you determine which number to use. You are actually going to use the height, the one straight up and down, which is 10. So I'm going to put 10 in here. I'm going to bring everything else down because I've already done my substitution, and the area is actually what I'm trying to find. So if I have the area equals snow cones 80 divided by 2, then I do my math here, I'm get the answer of 4 units squared. 40, not 4, 40 units squared. All right, and that's really all it is. I'm going to do one more example. All right, now our triangle looks a little different here, and I did this on purpose. First of all, it's an equilateral triangle, which has all sides that are equal. And good news for us is that the formula for a triangle is the same for any kind of triangle, whether it's a right triangle, an equilateral triangle, a scalene. You're always going to use area equals the base times the height divided by 2. Now this is a tricky one, and I did it on purpose because you're going to have a hard time figuring out what numbers to put in here. So if you go by and just listen to what I say, you'll easily be able to pick out the 2 sides that you're going to use. Remember when I talked about the doctor's office and you have to be measured standing straight up? Okay. Also remember that this is making this is the same as having 2 lines that are perpendicular, which looks like this, and they have a little box like this. Do you see the box anywhere in our picture? Yes, I see it too. It's right here. All right. So notice that the line going this way, and I'm making it in yellow, and the line going this way actually make that little box or the perpendicular lines. The 2 lines that make up this perpendicular angle right here actually are the 2 sides that you're going to use. So all you have to do is find the box, find the 2 lines that make up the box, and you have all the sides that you need. So when I look here, I see that I have 10 as my is my height. 10 is the height. Okay, my base is 12 because those are the 2 lines that are making up my perpendicular lines. So I'm going to put 12 in here. And everything's going to be divided by 2 once I actually do the math. Snow cones, this is 120 divided by 2. Bring down the A equals 60. And I haven't been putting any units on these, but you would put, if it was feet, you'd use feet. If it's centimeters, you'd use centimeters. Here, we don't have one, so we use units, but don't forget that we found area, so we square it. One last thing. What is the perimeter of that figure? What numbers would you use for the perimeter? Did you say for the perimeter I would do 12 plus 12 plus 12? Why would I add 12 plus 12 plus 12? Exactly. They go all the way around the outside. Remember, we're sealing off our perimeter. So this is on the outside, this is on the outside, this is on the outside. The 10 is on the inside. You don't use the 10. If you add the 3 12s together, you would get 36, and it's just going to be straight units. All right? So what you learned today was basically another 2D figure. You're going to need to know these because you're going to get into 3-dimensional figures. You're going to have to know how to do areas. And the triangle is easy to remember because you simply take the area of a rectangle and cut it in half. All right, answer the questions, get the notes, and we'll see you tomorrow.